All right, welcome back. Today, we're diving into something really cool, a framework for a system that's designed to evolve itself. And I don't mean by accident, I mean by design. This isn't just about your typical software updates. We're talking about a potential blueprint for how a superintelligent system could achieve constant, structured growth.
So let's just kick things off with a huge question. What if a system could just keep getting better? I mean, faster, smarter, more efficient with every single cycle it runs. Not just fixing bugs, but fundamentally upgrading its own core brain power forever. Think about that.
And that really gets us to the core idea here. We're looking at a massive shift in thinking. We're moving away from evolution being this accidental thing that just kind of happens to evolution being the system's #1 job, its primary structured goal. It's about building something whose entire reason for being is to get better.
And that something has a name: the Generational Iteration Framework. Now, what's really important to catch on this slide is the language used, structured and primary objective. See, improvement isn't some happy accident or a nice bonus here. Nope, it is the entire point of the system's existence. This comparison just lays it all out perfectly. You know the old way? Systems might get better over time with patches and updates that we humans push out. But in this new way, wow. The system is built from the ground up to drive its own evolution, one generation after the next.
So if a system is built to evolve, what's it actually trying to do, right? What are the rules of the road that keep it from just changing randomly? Let's take a look at what's really driving this thing. Turns out it's driven by 3 absolutely critical goals. First, just pure performance. Each new generation has to be faster and more precise. Second, it actively fights against getting old and clunky by constantly refining its own internal workings. And third, and this is so important, it makes sure there's sustained progress. It never, ever takes a step backward.
Okay, so a system that improves itself sounds awesome in theory, right? But how does it actually work? Let's get into the mechanics of it and see how this whole thing is put together.
Well, to handle this incredibly complex process, the system uses a special agent. Think of it like a conductor for this evolutionary orchestra. The source material actually gives it a name, Phys Flammeta, and its job is to run a very specific 5-stage cycle.
So here's the playbook. It's a 5-stage process. First, the agent maps out all the system's different cognitive layers. Second, it coordinates the timing of every single operation. Third, it gathers super detailed feedback from all those layers. Fourth, it uses all that data to automatically improve itself. And finally, and this is the clincher, it synchronizes everything. It makes sure the entire system evolves together as one cohesive whole. Now here's a quick but really important technical note. That first stage, identifying the layers, it actually depends on another piece of the puzzle mentioned in the source material, a workflow structure called Lyra. That's what defines the layers to begin with, which just goes to show you how tightly integrated this whole architecture really is. Okay, now we are getting to the secret sauce. This is the big idea, the unifying theory that makes all of this more than just a simple feedback loop. This concept is what really pulls everything together. This whole process has a name. It's called a meta-temporal task, and this is such a powerful concept. It means it's not just about what you improve. It's about the how, the when, and the order you do it in. The orchestration of the improvements is just as critical as the improvements themselves.
This quote just nails it. The structure, the schedule, the harmony of it all, that's what guarantees you get real, meaningful progress instead of just chaotic change. It's evolution with a conductor at the podium. I know this idea of meta-temporal evolution can feel a little out there, a bit abstract. So let's bring it back down to earth and make it concrete. We're going to use a couple of really cool analogies for this. So, we're going to talk about a self-tuning race car and a very, very sophisticated clock. Both of these are perfect for visualizing a system that's actively redesigning itself to be the best it can possibly be. Okay, first up, imagine a race car that doesn't need a pit crew. As it's flying around the track, it's analyzing its own performance and literally upgrading its own engine parts in real time. So with every single lap, its cognitive engine gets more powerful, making sure it's always getting faster. Or, how about this? Think of a clock where the gears aren't fixed. With every single rotation, they're subtly redesigning their own teeth so they mesh together more perfectly, more efficiently. The goal here is absolute precision, making sure that clock never loses even a fraction of a second of progress. That right there is meta-temporal refinement in action. And all of this leaves us with one last really big question to chew on. If a system is actually built on this framework, a system that truly never stops improving, always refining its own intelligence towards some kind of perfection, what does it eventually become?